Thank you for the introduction, and good morning, everyone, and welcome again to Nantes. So let's change topic for a while, and let's start with the introduction. So as everybody here knows, a promising clinical application for SMRA is represented by the calculation of biomarkers to quantify blood flow conditions. But this quantification still needs to be validated to assure its accuracy and reproducibility. And concerning the kind of validation, despite nowadays computational fluid dynamics has started to be widely employed to evaluate complex flow, its reliability and applicability are enhanced through experimentation. So in vitro validation is an essential tool to accomplish this task. For this reason, the aim of the present work is to design and manufacture a hydraulic test rig, also called a mock circulation loop, to be employed as a reference for PCMRI acquisition and wall shear stress calculated on them. Data to obtain were compared with those obtained with laser Doppler velocimetry that were instead corroborated with computational fluid dynamics. At this moment, it's crucial to do a short overview on laser velocimetry techniques, among which the most commonly employed are LDV and PAV. In both techniques, the fluid is seeded with tracing particles, but in LDV, we focus 2 laser beams on a measurement point, and we can acquire the Doppler frequency shift, enabling the acquisition of all velocity components. On the other hand, for PAV, we employ the laser sheet, and so the particle motion is tracked regarding images from which velocity is subsequently measured. So we obtain a projection of the velocity field. In this work, we employed LDV since it allows a more complete flow diagnosis. Let's switch then to materials and methods. The experimental setup was composed by a MRI-compatible pump, connection pipes, test section, and the reservoir. The test section was designed as a square channel to easily allow LDV. Its size was 25 millimeters long, compatible with a large vessel diameter, and during MRI, a plastic box filled with an agarose gel rounding the test section to simulate the presence of human tissues. The working fluid was a mixture of water and glycerol to mimic blood density and viscosity, and for LDV, 10 micrometers hollow glass sphere were added. Here reported the 3 steady flow rates we tested during our experimental campaign. This is the MRI protocol we tested during our campaign. We tested 2 clinical sequences, 2D and 4D, and you have the resolution reported in the slides. Venk was selected to be as close as possible as twice the mean velocity and to keep echo time lower than 4.8 milliseconds. Concerning LDV, data were acquired on an equally spaced grid, and then results were smoothed with a local polynomial regression. And as previously told, they were also corroborated with CFD. Later, data were degraded in resolution to match those of 2D and 4D. So basically, all LDV points were containing 1 pixel were averaged, resulting in a unique central point. Of course, a space shift occurred, but it was considered negligible. Signal-to-noise ratio was calculated with the following equation, in which sigma was the standard deviation of pixel outside the test section itself. And for blood flow quantification, flow rate was calculated with the Stalder methods based on B-spline interpolation, while for wall shear stress, we additionally tested the methods proposed by Potters and based on interpolation on a fixed number of points. Both methods were tested on a theoretical segmentation that was easily obtained from the CAD of the test section, in view to test them independently by the segmentation technique. So to resume, flow rate with the Stalder methods and wall shear stress with both Stalder and Potter methods. Statistical analysis was assured through 4 parameters: the Pearson correlation coefficient for the correlation of results, and you have the table we employ to score it. The root mean square error, so lower the value and better results. The ICC, the intra-class correlation coefficient for consistency, again a table employed to score results. And finally, the percentage error on flow rate and wall shear stress. Statistical analysis was performed on each acquired phases, and so the average values all over the phases are provided. Here we are with results. Briefly, the corroboration of LDV with CFD. So percentage error were fair of flow rate, and we obtain a strong consistency and correlation. So we can skip to the comparison among PCMRI and LDV results. The influence of noise for 2D results were fair. Concerning the percentage error, they were fair too, with exception of the Stalder methods. And if you switch to the statistical analysis for 2D results, we can state that with exception of the Stalder results, generally results showed a strong consistency and correlation, with exception of lower flow rate, in which noise may have a stronger influence. So for the 4D results, the influence of noise was lower, while errors were acceptable only for the Potter's methods, and this may suggest that Stalder methods may be influenced more by MRI resolution. To conclude this part, 4D results statistical analysis showed, with exception always of Stalder results, a strong correlation and a strong consistency, even better than 2D ones. And let's pass to the discussion of, to conclude this presentation. So we showed the feasibility of this kind of experimental campaign. We obtained good outcomes in terms of correlation and consistency. And concerning the blood flow quantification, we can say that Potter was more consistent than Stalder, and that maybe an alternative Venk selection criteria should be employed for further investigation, especially for 2D acquisition. Future developments of the present talk include the performing of a new pulsatile flow protocols with the same experimental setup, and employment of a new wall shear stress calculation method proposed by our group, of which you will have an overview on the poster session. Moreover, a new mock circulation loop will be developed to set up a more realistic scenario. So this is our team. We are happily located in Nantes, and the project was funded by the regional authorities by De La Loire, and I would like to thank you for your kind attention.